One of the most satisfying feelings you'll have as an instrument pilot is breaking out of the clouds at minimums and finding the runway right where you expect it. But you know that runways or airports aren't always easy to see when you're looking for them, especially unfamiliar ones at night or in low visibility. So you can use all the help you can get to know what to look for when you do break out, what the runway patterns look like, the kind of approach lighting the airport has, and where the rotating beacon lives. Well, at the bottom right corner of your approach plate, the airport sketch, you get all that and more in a relatively small package. So let's take a look at the airport sketch for the ILS runway 30 right approach at Bakersfield, California, and see what you'll find. And a really good place to start is at that little box at the top where you will find the airport elevation. An important number to keep handy. In this case, it's 507 feet MSL. The airport elevation is the highest point on the usable landing area of the airport. Now, let's take a look at the airport drawing itself. These hard surface runways stand out from the taxiways, ramps, and other surfaces at a glance. So you can quickly see that Bakersfield Meadows has parallel runways 30 and 12, both right and left. You can also see that the northeast runway over here is much larger than the other, but you don't have to guess how much. That's because they print the length and width on each one. The big guy over here is twice as long at 10,857 feet and twice as wide at 150 feet. Now take a peek at the bow tie across here. No, it doesn't mean that you need formal attire to fly this approach. Put your tuxedo away. That bow tie symbol tells you that this runway has a displaced threshold. It may seem odd, though, to see the symbol so close to the middle of the runway. So to ease your confusion, they added a little note that tells you that there's only 7,429 feet available for landing on 30 right. And you'll always see a landing distance note like that when you have a displaced threshold. Yes, they've moved the landing threshold over 3,000 feet from the end, probably to keep the approaches higher over parts of the city down here to the southeast. What else can you learn about this runway from the airport sketch? Well, check out this notation near the approach end of 12 left. It tells you that the runway goes downhill to the southeast at 0.4% slope. But you'll only see a note like that when the slope exceeds 0.3%. So if you're landing straight in on the ILS approach to 30 right, you'll land uphill, which makes stopping easier. And that's a good thing to know before you land. Now, when you're flying an approach in real instrument conditions, you'll want to know what kind of lighting to expect when you break out. And you'll want to know if you have to activate any lights yourself. This is especially important at night, but in low visibility conditions during the day, it may make the difference between seeing the runway and landing or not seeing the runway and needing to execute a missed approach. There's a lot you can learn about airport lighting just from the airport sketch. For example, if you're landing straight in on this approach, the first thing you would see would be the approach lights, if there are any. And now this circle with the A5 and the dot on the top tells you all about the approach lights for runway 30 right. What? You say you don't know what the A5 means? Well, the easy way to find out is to jump to the legend page L1 in the front of the book. That's where you'll find A5 listed in the center column at the bottom of the page. And here it is right here. As you can see, A5 tells you that runway 30 right has medium intensity approach lighting system with runway alignment indicator lights, abbreviated MALSR. Now the note at the bottom says that these lights look the same as an SSALR. So move up a couple boxes to the SSALR box and you'll find the lighting pattern you should see as you break out of the clouds on that approach. Now the little black dot on the top of the circle tells you that this system has sequenced flashing lights installed with it. You'll find those flashing lights, often called the running rabbit, very helpful for lining up with the runway in low visibility. Now these dark circles with reverse lettering tell you this airport has pilot-controlled lighting so that after the tower shuts down, you can control the lighting system by clicking your mic button. Now, did you notice these little white dots in the middle of the larger runway? And notice too that there aren't any dots here in the shorter runway. Well, those dots represent exactly what they look like. They tell you this runway has lights down the center line buried right into the pavement. Now, when you see circles like these with V and P, it tells you that you have visual approach slope lights. V stands for VASI and P stands for PAPI. You can tell that the VASI on 30 left and the PAPI on 30 right are pilot controlled. Why? Well, because of the dark circle and the reverse lettering again. But check out the VASI symbol for runway 12 left. Since that circle is not filled in, those lights are not pilot controlled, and that means they'll be on all night. Who's paying that electric bill at Bakersfield Meadows? As you might imagine, you can find the details about the VASI and PAPI systems in legend pages L1 and L2. Often when you're flying visually at night, you'll first identify an airport by the flashing green and white rotating beacon. Well, this star with a hole in it shows you where the rotating beacon's located, letting you know the beacon's relationship to the runway. Runway lights generally come in 3 flavors that directly reflect their ability to convert kilowatts into levels of light: low intensity, medium intensity, and high intensity. And they're abbreviated LIRL, MIRL, and HIRL. You can find out what type each runway has from a note somewhere in the airport sketch box. For our example, you can see that runway 12 left and 30 right has high intensity runway lights, HIRL, right there, while the other runway right here has medium intensity runway lights. And this last note tells you that 30 right has touchdown zone lights and confirms that it has centerline lights. Again, if you want to learn more about these abbreviations, you can check out the legend pages in the front. As before, the dark ovals with the reverse L's tell you that, as the pilot, you are the after-hours master of these systems, and you use the frequencies shown with the same symbol in the plan view. You'll often see the abbreviation TDZE, which stands for Touchdown Zone Elevation. Below it, you'll see an elevation figure for approaches set up for straight-in landings. In this case, at 490 feet, the TDZE is 17 feet lower than the official airport elevation, which you may remember was 507 feet. The TDZE represents the highest elevation in the first 3,000 feet of the landing surface. You will also see elevations for obstructions, like the control tower here in our example at 580 feet and the obstruction north of it at 642 feet. And we need to mention one more small detail. You're probably wondering what that skinny arrow at the approach end of runway 30 right represents, right here. Well, it's no mystery really. This skinny arrow simply tells you your track from the final approach fix. Now let's drop down to this table just below the airport sketch box. You'll use this table to time your final approach segment to the missed approach point if you're flying it without the glide slope as a non-precision approach. So, in our example, if you fly an approach of say, let's say your speed is 90 knots, it would take you 4 minutes to fly from the final approach fix to the missed approach point. Now sometimes you'll see a separate full-page diagram for an airport, and here's the one for Bakersfield. The enlarged airport diagram has a lot of detail that's intended to help you while you're on the ground. For instance, this is where you can find the exact taxiway layout and taxiway names, as well as key airport facilities. It's a great help if you're new to the airport or the visibility is really low. Jeppesen charts differ from NOS in that they do not use the airport sketch format on each approach chart. Instead, they print an airport chart on the back of the first approach in their sequence of the approaches for that airport, with detail similar to the NOS airport diagram. For larger, busier airports, Jeppesen prints a full page and sometimes even larger fold-out airport chart. For example, here's the one for San Francisco. So you'll find the information in the airport sketch or airport chart very useful tools for making a safe transition from instrument to visual conditions. And that's what it's all about, isn't it? Breaking out of the clouds and being able to see the runway. Knowing what the airport looks like certainly can only help that process.